These are comments for the intervals assignment, assignment 4 for Music 103. The first thing I want to point out is that the first page has 2 questions, and what I'm doing is dividing up the types of interval between perfect and imperfect. That means that when you look at these interval sizes, you can know that you'll be focusing on one or the other. So perfect intervals, unison, fourth, fifth, or octave, and imperfect intervals, seconds, thirds, sixths, and sevenths. So the first thing I always advise that you do is look at the diatonic interval size, because that's something that you can recognize straight away. That is what will give you this particular number, and you might recall from episode 5 exactly how we do that. We can distinguish between intervals that appear symmetrical on the staff or asymmetrical, and based on what you see there, you'll be able to choose one pathway or another. So you'd be looking for symmetries for unisons and fifths, asymmetries for fourths and octaves. So I put that in first, and then what you're supposed to be doing is applying ideas about chromatic interval size. That's what's going to give you the qualification, whether it's perfect, augmented, or diminished. So go for the diatonic size first, and I'd actually just run straight through all of the intervals in that way. You need to get that information in place first before you can accurately qualify it. The same thing will be true for the imperfect intervals. Go for the diatonic size first, and then once you have that in place, you will know from your chromatic size count how to qualify it. One thing that I would caution you about is making sure that you read the accidentals carefully. So if we look at these intervals that we have for the treble clef, you'll notice that because these are dyads, they are notes that are touching each other, the use of the accidental has to be placed very carefully. So check and see whether the sharp is over a space or a line, likewise with the flat. That's going to be crucial to determining what you qualify the interval as. Then when we look at the questions on the second page, this is all referring to the latter half, specifically of episode 8, where we talk about tuning and return to the use of interval ratios. So most of this information is something that you will be deriving from that final section of episode 8. And note that what you're not being asked to do is just talk about regular fifths and fourths and things like that. We're being very specific about the types of tuning we are interested in. So for example, for question 4, what is being asked is for you to provide a numerical proof in the way that I've shown in episode 8. You can also see it in the course notes about how these intervals add up. So a perfect fifth in just intonation, a perfect fourth in just intonation. You'll know from the information that you learned about in episode 8 that this is a ratio. If I'm doing it in terms of frequency 2 to 3 and 3 to 4, essentially, will they add up to a justly tuned perfect octave at the ratio of 1 to 2? So based on what you discover, you will be able to decide whether you need to actually temper the intervals, that is, change them so that they'll arrive at a justly tuned perfect octave, or not. So all you need to do is give us a yes or a no to that part of the question once you've actually put in the equation that you need. Question 5 is dealing with 2 guitars so that you can visualize this more easily, and I'd suggest that you visualize it in the way that I show in episode 8, where you can use the musical staff to notate the note heads that would correspond with these interval sequences. So we've got one guitar player who's working with just 3 strings, so you'd be drawing out, for example, you could start at a C below middle C in a bass clef, right a middle C, and then a C an octave above that, and write in the ratios that you're going to be working with, see what they add up to, and against that you will be comparing the 6-string guitar player, and what they are working with is a whole series of ratios. And remember, again, what we're interested in is what intervals a guitar player would be judging by ear. So if they're actually judging as acutely as they can, we're going to be talking once again about justly tuned intervals. So we have a sequence of 4 perfect fourths that is justly tuned. So again, in terms of frequency ratio, those would be the ratios of 3 to 4, and 1 major third, which is ratio 4 to 5. As you know from information you got both from episode 8 and that you can see in the course notes. So you want to add each of those sides up and see how they compare relative to each other. And again, I show you exactly how to do this in episode 8. I have a parallel question for this, so you'd be using exactly the same structure. Finally, question 6 is asking you to look back at the results that you got mathematically for question 5. And by the way, I do want you to be using precisely the way in which I lay out those equations so that you are showing the ratios either as ratios or as fractions and are balancing the equation on either side. Again, I show you all of this in detail in episode 8. Question 6 is saying then, if we're listening to just the 6-string guitar, like 1/2 of the equation in question 5, will its lowest string be in tune with a highest string in terms of pitch class? So that means, is it actually going to be forming a double perfect octave that is justly tuned? And that means it's going to have to be in some kind of pitch class relationship, which is 1 to 2 to the n, where n is greater than or equal to 0, right? So if you're wanting to be reminded of what the pitch class is, you can go right back to episode 1 where that's discussed. Okay, so those are my comments for assignment 4.